Okay, thank you, Dr. Friedman. All right, we're almost there. We're at the end now. All right, so as you said, my name is Carl Sims, and I'm a researcher or intern with Charles J. University. And what we looked at, we did a very interesting study. How many of us like Coke, Diet Coke or Sugar Coke? Hey, don't be afraid. It's okay. All right, we know that a lot of people drink Coke, Diet Coke, and Sugar Coke. And so what we looked at is we used these three main forms. We used Coca-Cola, and we looked at how it affected the body in regards to mice. And we looked at some of the things we looked at on was hepatic steatosis and muscle steatosis. And steatosis is pretty much just the accumulation of fat, whether it be in the liver or in the muscles. So, okay, so a little background.
We're a little bit late, so try to be a little faster.
A little faster, okay. All right. Okay. So sugar-sweetened beverages are the largest source of added sugar in the American diet. Sugar-sweetened beverages include, but are not limited to, sports drinks, energy drinks, and soft drinks, as many of you have said you like to drink. Epidemiological studies have shown that there's an association with increased obesity, type 2 diabetes, metabolic syndrome, and cardiovascular disease. One of the major sources of calories widely used as a sweetener is high fructose corn syrup. High fructose corn syrup is used in many of the soft drinks and processed foods we consume, despite the ongoing debate on whether it contributes to the obesity epidemic. All right, the high fructose corn syrup that we consume in our diet has been shown to cause increased insulin and triglyceride levels in the blood. Also, high fructose corn syrup has been shown to cause non-alcoholic fatty liver disease, which is pretty much accumulation of fat in the liver not caused by alcohol. Smoking also has been shown to contribute to non-alcoholic fatty liver disease and have direct adverse effects on the muscles. Previously, our lab has shown that the combination of nicotine and high-fat diet causes muscle and hepatic steatosis. Currently, the combined effect of both sugar, sweetened beverages, particularly soft drinks, and nicotine on body weight, food intake, and hepatic steatosis is currently not known. So, this led us into our objective. So our objective was to determine the combined effects of Sugar Coke, Coke, and Diet Coke. And what we wanted to do is look at how it affected the body weight, food intake, and ectopic lipid accumulation in the liver. So pretty much our protocol was that we got adult male mice on a normal child diet, and we gave them water for 4 hours during the day, followed by either Sugar Coke, Coke, or Diet Coke during the remainder hours of the 10 weeks. These mice received 12 daily intraperitoneal injections of nicotine for 10 weeks. Our controls were either fed a normal child diet, high-fat diet with free access to water, also receiving twice daily IP injections of nicotine or saline for 10 weeks. All right, so we had a total of 50 mice, and we divided those 50 mice into 10 groups. And so there were about 5 mice in each cage. And this is how we separated our groups. I won't go through each one for the sake of time. And so what we have here is the cumulative weight gain over 10 weeks, or pretty much how much weight they gained after the 10-week study. And as expected from many other studies and the studies that we have done, is that there is a dramatic increase in the green is the high-fat diet saline groups. And then also the darker green is the high-fat diet water nicotine group. So in the lighter green, there's an increase in body weight, which is expected because they're eating a high-fat diet. And then when we add nicotine to the group, there's also a dramatic decrease in the body weight. As we know, as we've been discussed before, nicotine is an appetite suppressant. And pretty much in the other groups, we didn't see much change as expected because it is a normal child diet and other data, and we have shown that there isn't much change in weight. And so the next objective we looked at was a cumulative food intake. So we were just looking at the food and how much they consume. So as we can see is that the Diet Coke ate more food, but in the other groups, looking at the sugar Coke, they didn't eat much food. But if we focus our attention to the Coke group, which is the orange group, we can see that the saline group is the lighter one, and also there was a decrease when we combined it with nicotine. And so this is just looking at the food intake. And now this is a cumulative caloric intake. So this is adding the calories from the beverage that they drank, also adding the food calories. So we combined the two, and this is the data we received, which was really interesting in that the Coke group, as we can see, they consumed a lot of calories, almost the same as the high-fat diet. And we propose that it's possibly because, especially when it comes to, we also took liquid intake. We saw that the Coke group drank a lot of the Coke. It's probably, and then they didn't eat much. This is probably because they were getting their calories from the Coca-Cola, which had a lot of calories in it. And then we can see that in the purple group, which is just the control group, there hardly wasn't much change within the group, as well as the sugar Coke and the Diet Coke. There wasn't much change. And then we had some pictures in which we were looking at the epididymal fat. That's just pretty much the fat, the visceral fat that is formed around the organ. And so we can definitely see that there is an increase in fat in the Coke and saline group, and it goes down from there, which is the sugar Coke, saline, Coke plus Nic, and the Diet Coke plus saline group. So there was more fat in the groups the pictures that we took in the Coke plus saline group. So one of the things that we talked about before, we said a hepatic steatosis, which is the fatty liver. And there's also another term called hepatomegaly, which just simply means large liver. And as we can see, there was definitely a large, which was really confounded, which was interesting to see that the Coke plus Nic had increased liver. It experienced hepatomegaly, and it almost reflected that of the high-fat diet, nicotine, and saline group. And there wasn't, and with the Diet Coke saline, there wasn't no increase in liver size. But there was a slight increase in liver size with the Coke and saline, but not compared to the Coke plus Nic and the high-fat Nic and saline group. So, looking at our results, I'll just quickly go over these. Weight gain was consistent over the normal child diet group, so we didn't see dramatic increases or decreases in the bar graphs in their weights. And also mice receiving Diet Coke with or without nicotine consumed more food, as we saw, food calories, when compared to the rest of the treatment groups, except that of the high-fat diet groups. And nicotine decreased caloric intake in the Coke mice, but not the sugar mice, not the sugar Coke or Diet Coke groups. So nicotine had an effect on these groups, except for the other. And also mice consuming Coke and receiving saline exhibited a similar caloric intake to animals on a high-fat diet treated with or without nicotine. And lastly, mice consuming Coke and receiving saline, so the Coke plus saline group had the highest caloric intake, but did not have increased weight, suggesting that their metabolism was higher. Somehow, I'm not sure, but it's possible that the metabolism increased due to possibly the sugar, or I'm not sure, the nicotine. Okay, And also, mice consuming sugar Coke and receiving nicotine or saline consume more calories than mice receiving water, but did not gain weight, suggesting that their metabolism also increased, but not as much as mice drinking Coke. So nicotine, when combined with Coke, appeared to cause hepatomegaly and hepatic steatosis, which was not seen in the sugar Coke or Diet Coke groups. So in conclusion, nicotine plus Coke, and that's the one with the high fat, high fructose corn syrup, may have detrimental effects on the liver. And lastly, strategies are needed to consume more water. We need to drink more water, essentially, as seen from the data. And as I said, if I stated, there you go, she has her water. And what we seen in this also is that this is a preliminary study, so we're going to repeat the study and then also get some statistics on this. But as we can see from the pictures, there is a detrimental effect. So thank you.
Take one question here. I thought people would ask this question. What do you mean by sugar Coke? Does anyone ask that question? Okay.
Yeah.
Right, so explain what sugar Coke is. And what's regular Coke? What's in regular Coke and what's in sugar Coke?
So what's in regular Coke? If we turn around a bottle, we'll say it's sweetened by high fructose corn syrup. And regular sugar or normal Coke, or some people call Mexican Coke, is sweetened with sucrose. So there is definitely a difference. And we can see with high fructose corn syrup, there is possible detrimental effects on the body.
And not the sugar Coke.
And not the sugar Coke, as we saw with the slide.
And Coke also has caffeine, which is a stimulant, and a diuretic. So we didn't think the diuretic was that important, but the stimulant effect may be somewhat important in some of the food effects.
Yes, Deshaun.
Do you see any abnormal things with the mice consuming